July 28, 2016. Guys, we just had a coronal mass ejection off the surface of the sun, and it is Earth-facing. Now, we've seen these before over the years, but this one is in a particularly bad location because of where our planet is right now. The satellite we're looking at, called the Solar Dynamics Observatory, is in a position to give us this Earth-facing view, and they call this type of coronal mass ejection geo-effective or Earth-effective. Now, if you look straight across that image, basically the equator of the sun, you notice that filament release is slightly above it, but it's as it ejects, it's ejecting downward. The Earth is below the equator of the sun. So remember that image. Another thing, guys, is that as we look at the different cameras, is it's one of the highest high-energy proton spikes that I have seen on the ACE satellites. We've seen a lot of activity lately, and the last video I did showing this the unusual ACE activity, I said that CERN would probably take advantage of that power, and they did, and it burned out part of their cryogenics or their cooling system. But I'll slow this down, and I want you to look at across the surface of the sun, the amount of area that is actually affected. You could tell it in the faster images, but check this out. It goes from the left side and ends up spreading all the way to the right side. It's very slow. You can see it go from purple to the red, and then you can see that the image lightens, and that's the secondary Hyder flare. Now, the models have not picked this up yet. You're looking at the one from last week that gave us the 3 6s in that triangle mode. Let's look at the early warning system, a different satellite. It's called ACE. It gives us a warning of incoming solar activity from our sun. Low energy electrons and protons are just, what's happening is they're overriding the satellite. You see the blank images in there. Now, in the center, this is radial speed, and that's solar wind speed. It went from 350 to 600 kilometers per second. The temperature has also risen very high. The density is down because sometimes the faster the wind, the thinner the density. Here is why I'm doing the video. High energy protons. This is called the solar isotope spectrometer. It takes a lot to move this one, guys, and this is Earth facing, and it's giving us an early warning of energy coming towards our planet. Right now, the quakes are mild, as you can look around. The strongest was a 5.1 southeast of Tonga. The rest are 3s and 4s. That could change. If I'm wrong, I'm wrong. That's too high of a spike on the high energy protons for me not to do this video. This is not an earthquake watch, it's an earthquake warning. Again, I'll stick my neck out on this one, and if I'm wrong, I'm wrong. I hope I am wrong, but that is a large CME. It is Earth-facing, and that spike is incredible. We're looking at CERN. They've been trying to get their beam back up and running at 6.5 TeV since they had that burnout, and now they're doing it. But notice the bunches are at just 1. It's easier to control, but they're going to change that. But these things are dead centered. Your beam 1 and beam 2 are not moving and scattering around these screens. They are set up for dead-on collisions, giving us a 13 tera electron volt collision. Again, are they going to take energy? Will they take advantage of this incoming solar energy, or will they back down the machine somewhat so they don't go through another burn through it? That will be interesting to watch. But again, I had to put the video up because of that high spike in the high energy protons. Let's watch the quakes overnight, guys. It's a heads up. Be safe.